In this section, we will discuss about curve fitting. I hope you know the basics of this curve fitting. So let us discuss the curve fitting method. So in this section, we will be discussing about the least square fitting method. Okay, basically this curve fitting will be if you are having some data points, given data points, and if you plot that with x and y axis, x, y here. So there are some points which is already given to you, and if you mark that on this xy plane, then let us consider some points like this. We're having some points like this. Okay, for different values of x, we are having different values of y. Okay, you can see here this is the x value, this is corresponding y value. You can see this point, this is corresponding x value, this is corresponding y value, and so on. Okay. Now, what we have to find out is the curve that will fit for this given data. That's what we have to find out. So actually, that curve has to pass through this all these data points. Okay, and in some cases, these given data points will be random. Let us consider it like this. So you are having one point here, another point here, some point here, and something like this. Something like this. Okay, similar to this one. So in this case, you cannot, if you are connecting all these points, it will be like this, something like this. Okay. But if these data are very close to each other, as we noted in the first graph, they are very close to each other, as you can see here. And if you want to get the trend in this case, then you have to fit that data points with some curve. Okay. So in this case, connecting all these points will give you something like this, as you can see. Okay, and if their separation is their separation is very small from a given line, then we can fit that these data points with a line. So if you consider some a line like this, it can almost fit this data, which means that the trend of these data points which are given to you can be approximated with this curve, and this is a line. Okay. You can use different equations to fit this data, and that will give you approximate curve for this given data points. For example, if you fit this with some exponential graph or exponential curve, then it will be something like this. Okay, so it depends on which curve or equation that you are using for fitting. Depending on that, it will change. It may be like this a little bit. I'm just roughly drawing that. Okay, this is not the actual curve. So you can use linear curve, you can use exponential curve, or you can use any polynomials with different degrees to fit this data. So basically, when you fit, then that will give you one particular curve with some equation. If it is linear, then you will be having something like y equal to mx plus c, or if it is exponential, then exponential graph, then you will be having something like y equal to some e raised to x or something like that, some constant. Okay, or if you are using any other polynomial with some degrees, let's say some 1 plus x square, something like that. Some constants may be multiplied with this x and x square. So these curves can be used, all these curves can be used to fit this data. Okay. So fitting means getting an approximate curve for the given data points. Okay, and here we will be considering the least square feet method. And in this technique, we'll be considering, for example, if you are having, so here we'll be considering least square feet. Okay. So in this least square fitting method, let us consider the given data points are x1, y1, x2, y2, x3, y3, and so on up to xn, yn. Okay. So let us consider all these data points in this let's consider all these data points in a xy plane. So this is how it look like approximately. This is your x, this is y, and if you consider x1, y1, all these data points. Okay, let us consider it like this. This is your first data point, second data point, third data point, fourth data point, and fifth one. So let us take the case with the linear fitting, which means that we are considering a line to fit all this data. So our curve is line, and let us consider this is your line that is fitting all these points. Okay, this is not the actual fitting, but I'm just considering this is the line which is fitting all these data points. So in this case, you'll be having different points for all these x values in this curve, this line. Sorry, this one has to. Okay, there is no point here. That one has to be somewhere here, and here, and here. So what is this? This x, this given y value, which is up as compared to this point which is on the line, okay, which is above that line. But this point, if you consider, which is below that line. Okay, so this is your actual data points. One is above and the other one is below that line. And here also you can consider this data point which is above uh, the, the the point which is on the line. Similarly, here also this data point which is given, which are below that line. So there are different data points which are above and below the line that is used for fitting. Okay. And if you consider this separation between this given point and the point on the line which is used for fitting, this separation, that is the separation between the point in the fitting line. So since we are considering line here, we are considering it as fitting line, or we can consider fitting curve. Okay, fitting line and given point, given data point. This is called as residual. Is called as residual. Okay, and if you consider any residual, that is, for example, the separation between these two, that is called as E1. Okay, separation between these two, that is the point in the fitting line and the given data point. So this is the separation. Okay, the difference between y values. and this is E2, that is our residual. We are representing it as by using E. So E1 and E2. So this difference that you consider is E3. So E1 will be the difference between these points. So let us consider this point on this line, which is f of x1. This point on the line, which is f of x2. That is the y value at x2 in that line. Okay. So then E1 will be equal to y1, that is the given data point, minus f of x1, that is the point on that line, and E2 will be equal to y2 minus f of x2. E3, that is the third residual, that will be equal to y3 minus f of x3, and so on. So what will be the En? En will be, that is the nth residual, that will be equal to yn minus f of xn. Okay. And as we have to give equal importance to all points, we have to consider square of these residuals. Okay. When you consider this line, so I will just draw that again, because it is, so we are having different points like this. And let's say this the linear fitting will give you some line like this. This is the approximate curve for all these data which are available. And if you consider this one, this is up. This is having the y value, this y value is above this line, and this y value is below this line, and here it is above. So if you consider all these values given data points, if you give equal importance to all these values, then we have to consider the square of these values, because this will be minus or the negative as compared to this line. This will be positive as compared to the line. So we cannot treat them as y, because one is positive, the other one is negative. So if you want to take them or give them equal importance, then we have to take square of all these data points, these y values. Then it will be positive always. Okay, so as we have to give importance to all these points, we have to consider square of these residuals. As we have to give equal importance to all points, we have to consider square of these residuals. So in that case, let us consider this one, y1 minus f of x1, that is this. Okay, let us consider the point in that line, fitting line, that is here, that is f of x1. So if you take y1, this is y1, so y1 minus x1 if you take, then that will be positive, because y1 is larger than f of x1. Okay, so this one will be positive. And if you take that same here, this is f of x, sorry, this is y2, and this is the point on this line corresponding to that x value for this y2, that is f of x2. So if you take the difference between y2 and f of x2, that will become negative, because y2 is smaller than f of x2. So this term, that is going to become negative. So if you want to give the equal importance to all those points, then we have to consider square of each of these residuals. Okay, so in that case, we can write capital E, which is equal to sigma I equal to 1 to n, that is sum of residual square. Okay, So this term you have to consider, and this is equal to sigma I equal to 1. What will be this? In here this n. Again, what is EI? EI is yi minus f of xi. And this has to be squared. Okay. So this is the total residuals. Sum of the square of each and every residuals if you take, and we consider that as E. Now for the straight line fitting, for line fitting, for this case, for straight line fitting, y should be equal to mx plus c. This equation that you have to use for that fitting. So yi will be equal to mxi plus c. And what is this? This is your f of xi. Yi is equal to f of x. Okay. And also, if you consider this term E, that is the sum of all those residual square, if you consider that, that has to be minimum. This, if you consider that, has to be minimum. Okay, so this, if you consider this one again for E, what will be E now? Because your f of xi is this term, that is your mxi plus c. So if you can substitute that one, then E will be equal to I equal to 1 to n yi. Yi is say minus f of xi will become mxi plus c, and the square of this we have to consider. And remember that this residuals, if you consider these residuals, then that term has to be minimum. This term E has to be minimum. Why it has to be minimum? Because if you consider this point, these two, okay, then the separation between these two has to be minimum. Similarly, if you consider these two, so then only we get that fitting, curve fitting. If your point is here, then you can suppose I will draw it here. Let us consider this case. If your point is here somewhere, okay, and some point here, there are some points, and here there are some other points, and there are some other points, and so on. So if you consider a line like this, then that is not best fit, right? So the separation between this point and the point on this line, that has to be minimum. That is the uh, condition. Okay, first, so that's where it is coming least. That is the least square fitting. Okay, so this separation has to be minimum. So when you consider the line, the separation between these two, the point on this and this y value, and that has to be minimum, and that has to be validated for all the points. To consider any points, it should be minimum. This separation square has to be minimum. Square of that value, separation value, that has to be minimum. That is why it is called as least square method. Okay, then only that will become the best fit. So here we have to consider this e value, that has to be minimum. That is the difference between that yi that is given and the point at the curve that we are considering. Take square of that, and that squared value, that has to be minimum, which means that this will be minimum when dE by dm should be equal to 0. That is the one condition, because in this case, we are having this variation, okay, dE by dm. That has to be minimum. That has to be 0. Then that quantity may become, that will become minimum. And the second one is dE by dx, sorry, dE by dc. dE by dc, that has to become 0. These are the condition for this term, to make this term has to become minimum. Okay. So these are the condition, to get that residuals of this term E to become minimum. So under this condition, let us consider first dE by dc. dE by dc, that has to become 0, which implies take the differential of this. Then we can have the value like 2 times sigma yi minus mxi plus this one is okay, c we have to give, right? Then multiplied with we have to see, so that is 1. So this is okay. This is the total terms. Thus this has to become 0, which means sigma yi, this should be equal to mxi. So in this case, if you consider sigma here, so this is sigma xi m into sigma xi. I'm just taking this mxi plus c onto the other side plus nc. Okay. So these two we don't have to consider because this term has to become 0 under for this condition. So yi minus mxi plus c, that term has to become 0, and just take this to other side. Sigma also there, so sigma yi equal to m into sigma mxi. So it's m into sigma xi plus nc. Why nc? This will run from I equal to 1 to n. So we'll be having nc. Okay. Similarly, if you consider dE by, or in form it is dou E by dou C, dou E by dou M. Okay, because it is dependent on both those values. We have to consider partial differential equation. So dou E by dou M, what will be that? Dou E by dou M, that will be equal to 2 times sigma, again 2 times sigma yi minus, in this case it is mxi plus c. Then we have to, we will be having one more minus xi term, which has to be multiplied with this. So this term has to become 0, and which means that yi minus mxi plus c into minus xi, that is equal to 0. From that we can write sigma, this one is, here we are having yi, so this multiplication is with this whole term. So here we'll get sigma yi xi, that will be equal to m into xi into xi, so sigma xi square plus c into xi, so sigma xi. So this we have to take the other side, so it will become positive, minus mxi into xi plus c into xi. All those terms will become positive. Okay. So this is the term. These are the two terms that we can get from these two equations. So here we are having sigma yi xi. So here we are having minus that we have to multiply with this. So actually this term will become minus on the other side also, because we are multiplying this minus with this minus, so that will become positive. So this, when it goes out to the other side, it will become minus mxi plus c into xi, sigma mxi plus c into minus xi. Okay, but that, sorry, minus will not be there, xi. So that minus, and here also we will be having one minus, because we are multiplying this minus xi with this yi. So that two minus will cancel, and we'll get this kind of equation. Okay, from these two conditions. So what we have done here, we have considered the residuals first. Residuals means difference between the points in the fitting line and the given data point by values. Okay, and that residual has, if you consider, if you are giving equal importance to all those residuals, then we have to consider the square of the residuals, and the square of residuals has to be minimum. It has to be minimum value. So to get that minimum value, this dou e by dou m has to become 0. Similarly, dou e by dou c equal to 0. From that, we have derived these two equations for that condition. So for that condition, we have these two equations. For the minimum residual value, square of that residuals, that has to become minimum. So in that case, then if you further solve this equation, solving these equations, these equations means, let us consider this as equation number 1, this is equation number 2. So in that case, we have to solve equation number 1 and 2. 1 and 2. Okay. So if you solve these two equations, then we can actually, how we can solve this? First, you multiply sigma xi with equation number 1. Equation number 1, that will give you sigma xi, sigma yi, that is equal to m into sigma xi, right, plus nc times sigma xi. Similarly, multiply n with equation 2, that will give you n times sigma xi yi, which is equal to m times mn times sigma xi square plus nc times sigma xi. So just multiply those values, and let us consider this is 3, this is 4. Now subtract 3 from 4, which implies what is this? Sigma yi. So what is sigma xi, sigma yi? So here we are having sigma. Okay, so sigma xi also will be there. This minus n times sigma xi yi. This will be equal to the remaining term, that is m into sigma xi minus this term is ncxi, that is same as this term, so that will cancel each other. Then the remaining term is mn sigma xi square. So from that we can write m equal to, what is m? If m is constant from here, then m will be equal to sigma xi sigma yi. I'm just rearranging this. You can multiply sigma yi with sigma xi or sigma xi to sigma yi, no problem. So then minus n times sigma xi yi divided by sigma xi into sigma xi minus n into sigma xi square. This is your m value. In the same way, we have to calculate what is the value of C. So we already calculated the value for M. So if you consider equation 1 now, equation 1, what was equation number 1? Equation number is sigma yi. This should be equal to M into sigma xi plus nc. So if you substitute M here in this equation for this to get this C, then we can get this C as, so just substitute this value. This will be sigma xi into sigma yi minus n into sigma xi yi divided by sigma xi into sigma xi. You can write this as sigma xi square also, no problem with that. N into sigma xi square. So this is sigma xi whole square and this is sigma of xi square. Okay. So this you have to multiply with sigma xi plus n into c. So this is the value of sigma yi. Okay. From this you have to find out what is this c. And if you do that, that particular from this particular equation, if you do if you find what is the value of c, then you will get it as sigma y so you have to multiply this sigma xi with these quantities first, that is in the bracket. Then you have to solve for equation for c. This equation you have to solve and you will get c, value of c. So that will be sum of y minus m into sum of x, m into sum of, sorry, this is m into sum of x divided by n, right? So this is sigma yi. Okay, so one way is you can directly substitute this xi and yi, all those values, and find out what is equation for c. Otherwise, if you know what is m, then you can directly get that by using this equation. That c value you can get from this equation. Okay. So now you are having both m and c. Once you have m and c, then you can directly write y equal to, for any x value, y of x, that will be equal to mx plus c. If you are considering your fitting line as straight line, fitting curve as straight line. So this will be mx plus, and you know what is m from this equation for the given that set of data, and you know what is c from this equation, and you can directly find out what is the value of y at a given x for that particular fitting line. In some cases, you can multiply this numerator and denominator with the negative 1, that is minus 1, and you will get the same equation for m. In some textbooks, you can see that also, which means that n into sigma xi yi minus sigma xi y sigma y divided by n into sigma xi square minus sigma xi into sigma xi. So that is also possible. Just interchange these two terms. Okay, then that is like minus 1. If you multiply minus 1 on numerator of this equation, I'm talking about m, minus 1 here and minus 1 here, then you will get this. If you can rearrange this equation, you can write this first term minus this term divided by this minus this term. So that will give you the same result. Okay, so this is how we'll find out the points for this fitting line. In this case, it is straight line. Straight line. Okay, so if you rearrange that equation, then you can also write it in a different form. But I think let us put it in that way. No problem. In the same way, we can also fit by using least square method. We can also fit those data by assuming the curve as exponential. So least square fitting method we are considering, and in that, if you are using exponential curve instead of a straight line, it's exponential curve. So for that, we have to first consider our y equal to some constant a into b raised to x. This is exponential. You have to take log on both sides. That's why log of y equal to log of a bx. So if you take this, this has to be, this is product, right? So log bx will become like this. Okay, so we have to first write log a plus log bx. Then we have to expand that. So this is log a plus x times log b. It's okay. Now, if you consider this equation, then it is like a straight line equation. So if you consider this as capital Y, this will be equal to your constant value C plus this is your another constant. Let us consider it as some M, or you can consider any value. Let if it is, let's consider this is A and this is B into X. Let's consider this as small x, right? So this is equation. So now if you consider this as capital Y and this is small x, then this is just like a straight line equation. Now find out what are these coefficients A and B. So the method that you have to use here is the same as that of straight line method. So you will be having given, you will be given different values for x and y. Find what is in sigma x square, all those things, and find out what is this A and what is this B. That you have already, we have already discussed for the case of straight line. Okay, so find out what is this A and B by using the same technique and substitute that. Okay, then from that you have to go back. So how we can get the value of y and sorry, small a and small b, this a and this b, from this equation? Small a, what is the connection between these two? Log a is, sorry, log small a, log small letter a, that is log a, that is equal to capital A, which means that small letter a, that is equal to, this value will be equal to e raised to capital A. Similarly, log b is equal to capital B. So this is small b will be equal to, this will be equal to e raised to capital B. So once you find out what is a and b, you will get e raised to a and e raised to b. And once you know these two, you are having a and b, then you will get your uh, exponential curve as y equal to a into bx. So for any x value, you can have this curve. If you know what is a and b, for any x, you can write. So which means that if your given data points are like this, something like this, okay. So in that case, if you want to fit this data points with the exponential curve, and if you know what is a and b, then you know what is this x value, x1, x2, x3, and so on. Yeah, these are data points. So if you want to find out what is corresponding point in that curve, which is exponential, then you just substitute a and b value, then with that x. For the first point, we'll be having x1 here and these values. So it may be somewhere, let us put it to somewhere here, if you calculate that. And again, if you put this x value, then you are getting y somewhere here, then the next x value will be getting somewhere here, next x value will be getting somewhere here. Okay, for this one. So you are having some value here, and for this one, let's say that value is somewhere here. Okay, and for this one, it will be somewhere here. And the last one is somewhere here. So this is the y value by using this equation with some a and b that you have calculated by the linear method by using this equation. Okay, then you substitute that in this equation, then you will be getting y equal to something like this. So this is your curve that is for this particular data points. So it will be like an exponential, maybe increasing or decreasing, it depends on the value. Okay, so now you can see this y equal to abx equation that you can use to fit your data points by under the least square technique, along with that idea that we just discussed in the case of linear technique. Okay, linear fitting. So that's all about least square method, least square fitting method with the straight line and exponential curve, and we'll discuss the program for this also. Okay, now we will discuss an example. So here we are having this data set, as you can see in this Excel sheet. These are the x values. Okay, and I am having that equation for m and c here. Okay, and this is the x data, this is y data, these two represent xy data that is given, and if you consider x square, that is the square of this term, x value, so this one will be b5 into b5, you can see it here, that is 1 into 1. In this case this is b5, so this is 1 into 1, that you will get x square. For this 2 into 2, that is 4, and so on, you can get all the values of x square here, and xy is the product of this column, this particular cell, and this cell. Okay, x into y, so 1 into 2, that is 2, 2 into 4, that is 8, 3 into 7, that is 21. So you just have to multiply these two first, and then just drag those values. Okay, so I will just show you that if you don't know that. So this is, I need to calculate what is xy here, so I will just write sum, then x into y. So you will get first element, just drag that, you'll get all the xy values. Okay, now if I want to get sum of x, that is sigma xi, this will be equal to, just select all these column and just press this auto sum, that will give you sum of all those values. And similarly sum of y, all those y values is 48, and sum of x square, if you consider, that will give me 91, and sum of xy, if you take, that will be 211, the sum of all these values. Now we have 6 number of data points, that is for x values. This is sum of x, this is sum of y, this is sum of x square, this is sum of xy. Okay, now this is n equal to 6, 6 data points are given. Okay, so n equal to 6, and what will be m? My m will be this quantity 2.4571. So how I can get that? We'll just write that here. M equal to, I'm just writing here, m equal to, what is my first term? Sigma xi. You can see from here the equation, sigma xi. Sigma xi will be giving you what is that cell? This is sigma xi. So sigma xi into sigma yi, that is the column, minus n into, what is n? 6, minus 6 into, so I will just write 6 here, then multiplied with sigma xi yi, sigma xi yi. So that is this, use this bracket here also. Sigma xi yi, that is the sum of this product xi yi, that is this one. Because that divided by, I have to take the sigma xi into x sigma xi. So sigma xi into sigma xi is this cell, multiply with the same cell, sigma xi into sigma xi, minus n into sigma xi square. So n is 6 sigma xi square. So that is this one, sigma xi square. So this is the m value. Now, if you know what is m, then you can find out what is c by using this equation. You can see here. So that will be equal to sigma yi. What is sigma iy? Sorry, sigma yi. Sigma yi is this column minus m into, what is m? M is this column. Okay, m into sigma xi. So I'll just here m into sigma xi. Sigma xi is this column. Sigma, I think here. So this is y sigma y and sigma y. What is that? C11 is that is okay. So this is H5. H5 is standing for this one m. So that H5 m into sigma xi. Sigma xi is this two. Do that. So this is sigma yi. First term is sigma yi. That has to be subtracted minus m into, this is minus m into sigma xi. So sigma xi is this one. Sigma xi. Now all this term has to be, that is divided by 6, that is n. So this is your c value. So once you have this m and c, then you can take any x value and you can calculate what is the corresponding straight line, okay, for that data set. So for all these x values, you will get this. So if you want to find out what is y with that line, so this is, let's say, y which is equal to mx plus c. Okay. So that you can calculate by, what is this m? M is this value. So put equal to m times with this into x, then plus c. This is c. And this is your y value corresponding to that 1.85. And if you take it up to this, you will get something else. So there's some problem with that. Let me write it. And then into, I don't know, it is multiplied like that. Let me put here also. M G16 is, this should be G15, right? M5 into mx, so this one plus c is this one. So that is the value. And no, it is not working. Anyway, so I will just write here also. So my m is here and my x is this one for third point, and then plus C. One, this is the value. So here also equal to M into X plus C. Here also equal to M into X plus M M into X plus. So these are the points corresponding to the given data points. Okay, for this by using the calculator M and C. Now, if you plot this with respect to X, what you will get? Let me plot that. So we need this X also. So I will just insert this. I will just scatter plot. Let's put it as line. Okay, so this is the line. That is the straight line that you can get from by using this calculation in the least square method. You can get this line for this set of data. And if you want to see that data also, then I had to add this data. Let me see whether it will work. So add, let us put X values as this and Y values as this. Okay. Now I have to change this one should be plot with the dot. Okay, now you can see that. So this dot, this squares that is showing you this data set. Okay, the given data points, and that line which is in the blue color, which is the line that we have found by using this particular square method. Okay, so now you can see that this line is fitting for all those data points that is given here. Okay, so this is this blue line representing the curve fitting, or the straight line which is fitting the data points given in this problem, and the slope of that line is m, that is 2.457, and the constant c, which is minus 0.6. Okay, so this is the method. This is the least square method. So here we have used only the straight line. Similarly, you can find out the value for the same method you can use with the exponential curve also. Okay, now let us move to the program section. I will just share that tab here. Let me see. So, so I hope you can see this program. I have already written the program here. So this is n, which is equal to the integer of input, enter the number of points. So how many number of points you have to enter, that you have to give in this line, which means that the number of data points that is available to us, and that is taken as integer value. Okay, then we have sum x equal to sum of this. Sum x means sum of x values, xi, that is sigma xi. Okay, so sum of x values equal to sum of y values equal to sum of x square. Sum xx is sum of x square values, and sum of xy. All those values I have given 0. That is the initial condition, initialized to 0. So all my sigma x, sigma xi, sigma y, all those values are 0 now. And then for I have given here a loop, a for loop, and here I have taken I in range of 1 to n plus 1. Okay, for I in range of 1 to n plus 1, which means that if you are giving 6 data points, it will go up to 6 plus 1. So, but actually it is starting from 1. That's why we are giving n plus 1 here. So if you provide 0, then it is up to you, because the index will start from 0. So since it is starting from 1, so we have n plus 1 up to n plus 1 it has to go. Okay, then we have x equal to float, that is the value that you have to give for x data, then x values in the given data set, and then y values you have to give here. Both I have taken as float values here. So input enter y values. All these things you can do in different way. You can give both x and y at the same time, separated by comma and all those things. This is the here I have used the symbol steps. The number of steps are not minimum, but I have used the symbol step here. So x equal to float, give the x values and then y values. So for given I, so for example, I equal to 1, we have to give what is x, what is y. Then sum of x will become sum of x plus 0. Initially sum of x equal to 0 plus x. Okay, so the given x value will be added with this sum x. Okay, that will become, so the first element will be added with sum x, which means that the sum x will become the first element. Similarly, sum y also, sum y equal to sum y plus y. This sum y equal to 0 because we have initialized it equal to 0. So 0 plus first value of y and so on. So this is sum of x square, that will be equal to sum of x square plus x square. Okay. And sum of xy, that is equal to sum of xy, that is initialized to 0 here, you can see here, plus xy. Now this xy is not 0 because we have given x and y here for the first I value. And again it will go to this for loop. It will check whether this I value is reached to n plus 1. If it is not, then it will again uh, go into, if it is not more than n plus 1, it will again go to the, if it is not more than n plus 1, it will go to this step. Again it will ask you what is the x value, which means that you have to enter the next x value. Okay, and also next y value, and this process continues, and each time sum of x and sum of y, sum of x square, sum of xy square, they will be added, they will be changed. So each time x, sum of x will be changed like x plus next x plus next x plus, like that. And when it reaches the final value, at that time it will become n plus 1. Okay, and it will run, and then if it is going beyond that range n plus 1, that is if it is going beyond the data points, number of data points that we are having, then this loop will exit. Okay, this loop will exit, and then it will directly calculate what is this m and what is this c. So I think this c, I should change it to sum y minus sum x times m times sum of x, right, divided by n. This is equation for c. You can also take print both in the same line, m comma c, that you can give, no problem. So I will just run this code. So here we are just calculating that m and c. Okay, that is already know the equation, and then you have to print those m and c values. Okay, so that's what we have to do here. Maybe this equation I have just interchanged with the multiplication of -1. So anyway, that you can change here. Change that here. That don't have to be confused here. So I'll just change in the same way. Sum of x into sum of x. I will just run this program. So first it will ask me number of points or number of data points. I will put 6. That is what we have done in the example. So same value I will give here. and the values are x, first x value is 1, y value is 2, the next x value is 2, y value is 4, the next x value is 3. This data I have used for that example. Okay, so 3 and 7 for y, and next is 4. For 4 we have 9, then 5, for 5 we are having 12, then 6, for 6 we are having 14. So after this it has to give me what is m and c. You can see it is 2.457 and minus 0.6. So this is the same what we have got in the calculations in Excel sheet that we have just